Okay, so I'm just going to do a really quick tutorial just so you guys, have a reference for how to use your ZBD file. Remember, ZPrint, some of you downloaded ZEdit, we want ZPrint because print is the slicer software. Will read your documents via an STL document. So you want to make sure you export selected, do not save as from Rhino. You want to export selected a STL file, a stereolithography file. And that way ZBD will, or no, sorry, ZPrint will open it. So I will go to where did I leave it? Bear with me for a second here. No. No. Did I dump it some? No. Go. So I'm just going to open up this random 3D print that I made. Okay, it's going to open up this dialog box. It's going to have my X, Y, Z coordinates, or whatever. This is the important box. Make sure this is in inches. Always have this in inches. Do not do millimeters unless you really feel like doing it and your machine is in millimeters, but it's not, so it's in inches. Don't do it. And we're just going to keep it on the ZP150. It doesn't quite matter what the powder type is. That's something for them to decide. We're going to hit next. It's going to open it. Ta-da! And I am going to have this thing sitting in ZPrint. You click and hold your scroll wheel to rotate around. This slicing software is never really that great at computer modeling. It just kind of reads things. So moving around is very tricky sometimes. You see I have this little shape that I had from the tutorial video. Okay, so like Mara said, there's no black shaded objects. Anything that's black shaded and has no tone to it is going to it will not print. So that is an error, and that is something you will need to solve. So it could be some naked edge, probably somewhere along some connection point that you'll just have to address. Right now, we're just in the standard view, which is this sort of L view. We have two other ones. We have our 2D view, and we also have our 3D cut view. And we also have these two plan views. So if I click this one, it's going to open my 2D view. You can see it's got nothing on here, and that's because it's starting to cut from the very bottom. This little arrow right here is where it will cut from, and if I drag it, it will start to cut things. So you can see this is how it's going to slice. I cut through, it's kind of a neat pattern. You can see it's cutting through. So this solid object, for example, so if I cut through, so right here I'm kind of through this surface port right here. This is one whole layer that it is going to print. So it's going to bzz all the way through here, and it's going to fill all that in. So you want to be aware, if you have a whole square that's filled in like that, black, that's just going to take forever to fill through. So you just want to maybe shell it out, kind of remove some material that will also reduce the cost. Remember, if you are at $100 and you're over 24 hours in your print time, you need to come see me or email me as soon as possible, because that means there's something wrong with your file, and it could just be as simple as scaling it down a little bit. That'll reduce the cost and time. But it may be a matter of kind of figuring out ways to remodel your material so that it's a reasonable 3D print. So another option I have is if I unclick 2D, I can click this button, and this is going to draw a line, as you can see, a blue line wherever I have my yellow line. So you can see I'm dragging it up and down, and this blue is moving up. This is going to show me if I have any non-manifold edges. So when you're looking for non-manifold edges, you are looking for two edges that are essentially touching. So if for somehow this line right here and this line were touching somehow, that would be a non-fatal manifold edge, and that would essentially fail. It means they're just not quite connected. I saw a lot of people on Tuesday as well have they kind of had, so imagine these little edges right here where I'm pointing right here. They had like geometry building off that edge and extending out. That's a non-manifold edge, and that won't work. So you just want to be aware about that. Now, you'll notice on my file that it's not quite curved. It's what's called faceted or tessellated right now. It's kind of been built up into triangles and squares to kind of approximate the curvature. That is what a slicing software will do. In Mara's tutorial video, she actually shows you how to make a mesh. That is one way of kind of testing whether or not your file is good. But you do not need to export out a mesh to STL in order to 3D print. You are more than capable of 3D printing a poly surface that has the same properties. It's a watertight solid and has no non-manifold edges. So you do not need to do the mesh step. If that seems confusing to you, don't do it. Meshes are used a lot for other things, CNCing sometimes, and other 3D modeling software. So you just want to be aware of that. So you're more than capable of entering or exporting an STL just from a straight poly surface that is totally closed, has no naked edges, and has no non-manifold edges. Okay, other than that, I'm just going to go to File, 3D Print Time Estimator, and that is going to generate my big dialog box with kind of all the goofy information in it. So you can see it's going to estimate a time for my print. It's going to say 3 hours and 2 minutes. The higher it has to go, the longer it will take. So what I mean by that is the taller it is. So if you have a tall object, you might want to consider flipping it. So maybe in Rhino you rotate it so it's on its side. You do not have to make a 3D print that is exactly in the same position as your Rhino file is, nor does it have to be in the same piece. If you need to have two pieces and you need to glue it together, you're more than capable of doing that as well. Just regular glue should work. Okay, so I have my time. I have my object. You can see here right now it's reading in cubic centimeters. We don't want that because we can't measure in cubic centimeters. You're more than capable of just converting it, but that's kind of, we don't want to do that. So we're going to go to settings. We're going to go to general preferences, and I'm going to go click inches. And you also want to do Fahrenheit. The reason there's temperatures in here has to do with PLA 3D printing. Just for your reference, PLA printing uses what's called a low melting point plastic, a PLA plastic. PLA it stands for some gobbledygook, whatever plastic. It's just an abbreviation for that. It's a plastic that will melt at a very low temperature. So that's why we read those temperatures on here. I'm going to hit OK, and then I'm going to go back to my file, print time estimator. And now you can see it's in inches. So I have 4.74 cubic inches. All I have to do now is go to DAP space and look on the page and find where the information that lists the price per cubic inch. I multiply that by the cubic inches listed, and then I go to price per minute, and I multiply that by the number of minutes. So you have to transfer that hours into minutes. That's not hard. So that's essentially what 180 minutes into 182 minutes. Okay. What I want you guys to do, and I'll send a quick email about this, is I want you guys to copy most of this information. So you can just copy this like that, or you can actually save a .txt file, which is just straight text. It doesn't matter, whatever you want. I want you to put that in a Word document that lists very clearly your approximate price and your approximate time, in a nice graphic way. It doesn't have to be fancy, just a Word document. And I want you to have that with you when you present. You don't need to hang it up. But that's something we're going to need. other than that, you are all set to go for 3D printing. You can save your STL file and submit an STL file to the RCP. They would actually sometimes prefer the STL. However, you also can just say, I want to save as a ZBD file, and save a ZBD file. I know Mara was asking for ZBD files, so if you feel comfortable turning in a ZBD file, that's fine. You are more than capable of turning in or more than welcome to turn a STL file in. I can read STL files. Many of you have already sent me some STL files. I can read that in ZPrint. Other than that, you guys are good to go. So good luck 3D printing, and we'll look forward to seeing what you guys have on Tuesday.